We can. Parker, you want the lights for us there, dude?
Yep.
You just called him.
Yeah. What do you want me to call him?
I don't know. You already called him Parker.
Parker? I'll call him
You said Parker hit the lights.
Mr. Cougar fan?
Well, you said Parker hit the lights, dude, so you like called him by his name.
So we have this parametric equation. X equals 2t plus what? Y is equal to parentheses t plus 1/2 quantity squared. Now it's been a while. It's been what, since last Friday? So just take a moment and look at part B, the example that we did at the very end of class last time. It's the same directions. You need to eliminate the parameter to write this as a rectangular equation. So the guidelines were choose the easier equation to solve for t. Here's an obvious choice here. Well, I don't know. Fairly obvious, I would say. The one on the left or the right? Wrong. No, you're right. No, you're left. The one on the left.
Wow.
Solve for t on the one on the left.
Congratulations.
Right?
That was awesome.
So x minus 1 over 2 is equal to t. X minus 1 over 2 is equal to t. There were really only two guidelines. Guideline 1 was to choose the easier equation, solve for t. The second step was to substitute into the other equation. So now we take this, substitute it. So we're going to get a function of x here, looks like. So y is equal to quantity x minus 1 over 2 plus 1/2 squared. Let's clean this up a little bit, though. That looks kind of weird. Kind of like you guys. Luckily, they have a common denominator. So, what's it going to be? It's going to turn out to be x over 2. Quantity squared, or just x over 2 to the second power. I know I'm skipping a few of the arithmetic steps in between, but I'm pretty sure you guys can handle it. And then, just to get rid of parentheses, x over 2 to the second power is x squared over 4. So what is that? Y equals x squared over 4. Bueller. Come on now. It's a parabola facing up. Y equals x squared is a function. That means it has to pass a vertical line test, so it has to be a vertical parabola. Whereas, I was kind of mentioning this as the bell was ringing, but the one we did last time, this one here, that's a sideways parabola because it's an x equals y squared equation. So this would be a sideways parabola that's not a function. Anyway, let's make this a new example, but it's still the same idea. We need to write this as a rectangular equation, but the way that we do this is slightly different. So this is example... Is it only example 2? It might work. Okay. Example 2. Now, these directions are going to... Well, I'm just going to write these because this is what the book has as directions. So just... Well, let me see. Hold on now.
Do you want us to write this down? Or
Yeah. The position of an object in circular motion y. So here are the parametric equations. X equals cosine of t. Y equals sine of t, where t is greater than or equal to 0. Here's what you need to do, and this is exactly what the homework would have you do for a problem like this. Describe the path of the object by stating, now if this is in a circular motion, then we need to find out the radius of the circle. So by stating the radius, the position at t equals 0, so where does the object start when time is beginning, when t equals 0? The direction, meaning does it travel in a clockwise direction or a counterclockwise direction? Holy moly, and if that weren't enough, and the time it takes to go around the circle, to go around one revolution. Wow.
You're trying to make our brains explode.
I know.
Because this is the simplest thing we've learned all year.
No, this one's kind of a, you just have to learn how to do it. Once you learn how to do it, it's not that bad. You just have to practice a few of them. So in order to answer this question here, stating the radius, some of these other ones could probably be answered by leaving it in parametric equations, but to find the radius of this circle, we need to write this in the standard form of a circle. So we need to write these as a rectangular equation and not a parametric equation. So here we go. This is now slightly different than the guidelines I gave you before. In particular, when these are describing circular motion, like these are, x equals cosine t, y equals sine of t, there's a little bit different way that we can do this. So here we go. If x equals cosine of t, then would you guys agree that x squared equals cosine squared of t? Would you guys agree with that? Just square both sides, right? And if y equals sine of t, then what can we conclude? Y squared equals sine squared of t. Okay. Now I want you guys to think for just a moment. Where the crap are we going with this? Let me ask you another question. What does the equation of a circle look like in standard form? Not in parametric form, but in standard form, what's the equation of a circle? X squared plus y squared equals the radius squared, right? Where are we going with, what can we do? What, let me ask, write this question down. What is x squared plus y squared equal to? In standard form, it's equal to the radius squared, you're right. But if x squared is equal to cosine squared, y squared is equal to sine squared, then isn't x squared plus y squared equal to cosine squared plus sine squared? Which then, that's equal to what? So x squared plus y squared is equal to the sum of the right side of these equations. That's equal to cosine squared plus, or sorry, cosine squared of t plus sine squared of t. Now use the Pythagorean identity. What is cosine squared plus sine squared?
1.
1. So x squared plus y squared is equal to 1. That's the equation of a circle in standard form. Now we can answer at least this question here, stating the radius.
Grabbing the square root of 1 equals x plus 1.
The square root of x squared plus y squared. What's the radius? Which is 1. Radius is 1. So that answers the first question. Radius is equal to 1. Now to answer the other questions though, I would use the parametric form of these equations rather than rectangular form. So make a little box like this. Or not a box, a table. Let's make a table. We have t. Here we have x equals cosine squared, or cosine of t, and here we have y equals sine of t. The other question was the position at time equals 0. So let's choose the value of a parameter to be 0. That'll give us a coordinate location for x and y. That'll give us the starting value. What's the cosine of 0? Think about the unit circle. We have at 0 we have a point of 1 comma 0. Oh, come on. Dang it. There it is. Unit circle right here, we have a point of 1 comma 0. So the cosine of 0 would be 1. The sine of 0 would be 0. So this answers the other question. What's the position when t equals 0? What's the position of our object? Position, let's answer that question. The position at t is equal to 0 is 1 comma 0. That's where that object is on the coordinate plane. Now, how do we know where the object travels? Does it go in a counterclockwise direction or does it go in a clockwise direction? How do we know that? Start plotting some other points for t. This is where time equals 0. Let's choose why am I choosing such a weird value of t? Pi halves. Because it's easy to find cosine and sine. T could be anything like 0, 1, 2, 3, 4. But those wouldn't be very easy to find sine and cosine of. So I'm choosing some radian measures here. So at pi halves, that's at the top of the unit circle. That has a location of 0, comma 1. So what's the cosine of pi halves? 0. And the sine of pi halves is 1. So take a look at what's happened, you guys. Our object started here at 1 comma 0, but when t elapsed to pi halves, our object had traveled up to 0 comma 1. So what does that mean about direction? What direction is the point traveling? Counterclockwise. So the time takes us, see the position at time. Oh, the direction. Direction is counterclockwise. And finally, the time it takes to go around 1 revolution. This, yeah. The time to complete 1 revolution is 2 pi.
So if the radius is 1, it's pretty much just the unit circle, right?
The unit circle, yeah. Let's do 1 now, though the radius changes a bit. Let's see what effect that has. Alright, cool, cool. Part B, same example. x is equal to 2 sine of t, y is equal to 2 cosine of t. Same directions. We need to find the radius. We need to find the position at t equals 0. Blah, blah, blah. So, help me out. I'm in need of assistance here. I need your help. Come on. I guess we could do that now, yeah. Wait, what was your suggestion?
We're going to do the x squared plus y squared equals 2.
Okay. You're really close. That's a good suggestion. Here's what I'm going to do first. This could maybe be done as a second step, but just to avoid confusion, I'm going to do it now. Divide each of these by 2. So this is going to become x over 2 equals sine t. And over here we're going to get y over 2 is equal to cosine of t. I'm going to do that right off the bat. I see fewer mistakes when it's done this way. Now, just like in the last part, we've got to square everything so we can have a cosine squared and a sine squared to use that identity. So this changes into x squared over 4 equals sine squared of t. This changes into y squared over 4 equals cosine squared of t. So if we add the two expressions on the left side of each of these equations, that's going to be x squared over 4 plus y squared over 4. That means we also have to add the right side of each of these equations. So that's sine squared of t plus cosine squared of t. But we know what that equals. Equals 1. So now we have x squared over 4 plus y squared over 4 is equal to 1. Now be careful here. This is not really the equation of a circle yet. I guess it is, but it's not really in the form we want. We could. We could do that, but yeah, we don't want to have any denominators for a circle. Denominators, we only want a denominator for an ellipse or a hyperbola. So yeah, multiply this side by 4 and then multiply this side by 4 to clear the fractions. And that gives us the equation x squared plus y squared is equal to 4. Yes, absolutely. This is not the radius, you guys. Did you hear that? The radius is not 4. It's the square root of 4. So the radius now is... the radius is 2. Okay, but now that we've answered that particular question, we can use the parametric form to answer all the others. So make another table. T, and then what did x equal? X equals 2 sine t, so x equals 2 times the sine of t, y equals 2 cosine t. So we have to answer the same questions, first of which is, where is our object when time is 0? This could be a particle moving along a path, or it could be anything, just some object moving in a circular path. So, if t is 0, what's the sine of 0? Think unit circle. Sine of 0 is... Ooh, I'm hearing two different numbers. Here's the unit circle. Here's the 0.1 comma. This is where it would equal 0. The sign would be the y value, right? So the sign of 0 is 0. 0 times 2 is still 0. So the x value at that point is 0. Now, for the y-ordinate here, cosine of 0. Cosine of 0 is 1. 1 times 2 is 2. So in regards to where this point is, 0, 2, that's at the top of the circle, right? 0, 2. So, I'm running out of room here, dang it. So, starts at the point 0, 2. So, that's a unicircle. If we're thinking about the circular path of this object, then the radius of this circle is 2. So that's a distance of 2, but the object starts here at the very top of it. Now we have to decide, does it travel in this direction or does it travel in that direction? Does it go counterclockwise or does it go clockwise? How do we know? Now we got to see what happens when we plot some other values of t. So we can use pi halves again if we want. Yeah. Questions are good.
Well, I was going to ask if it was possible for, I figured out this question, but like, if it was possible for the next point to be like all the way around and one point, so you think it's going counterclockwise or really it moves clockwise all the way around. But then I thought if you're plotting just the next frame.
That's why you want to keep it relatively close. So at pi halves, what's the sign of pi halves? 1. 1 times 2. So now we're there. And then the cosine of pi halves is 0. 0 times 2 is 0. So take a look at the path of this object. It started here at 0, 2 when time was 0. But when time was pi halves, that object has traveled down here to 2, 0. So the path of the object is clockwise. Travels clockwise. Oh, I can't even spell. Clockwise. There we go. Well, check this out, you guys. When time was 0, it was here. When time was pi halves, it traveled a quarter of a circle. So in another pi halves, it's going to travel another quarter. And another pi halves, it'll travel a quarter. And then another pi halves, it'll travel a quarter again. So it's 2 pi again. So makes 1 revolution. In 2 pi, whatever the unit is for that t value, 2 pi seconds or 2 pi. No, it won't always be 2 pi. Yeah.
So, but can that be different sometimes? So, could you plug in pi halves and it would be like halfway around the circle?
Yeah, yeah.
What
would make, that's a great question. What would make that different? Because it doesn't always take 2 pi units to travel a complete circle. Can anybody think of an instance? Because you have a problem like this on your homework where it isn't 2 pi.
When it's inside the sun.
Yep. So if the parametric equations were like this, I don't want you to change anything on your notes because you might get confused, but what if the parametric equations were x equals sine of 2 theta? What effect does that have? Think graphing-wise, you guys. Graphing-wise, sine of 2 theta. What does that do to the graph? Changes the period, but how? Does it expand it or shrink it?
Inside is opposite.
Inside's opposite, so it actually shrinks it. So this would take less time to complete a revolution. Take pi to complete a revolution. So yeah, if the number occurs inside the function, it takes less time to complete a revolution.
So if it's plain, then it'll all take 2 pi, but whatever's inside of it, just take pi.
Yeah, you can think about it that way, yeah.
So at that point, would you just plot a smaller point to find what direction it's going? Because if it,
Yeah, because if you
get a
do,
point that's all the way across, it could be counter.
yeah, because if you do pi halves, that would be halfway across. So you're not. So in that case, I would do pi fourths. Yep. There's one more objective we haven't got to yet. Let's do. Man, what example is this? Example 2. What is So this will be example 3. Here we go. This will be our last one. We've been given parametric equations, and then we found the rectangular equation for it. Maybe something a little different. We have to find our own parametric equation. So here's example 3. Find parametric equations for the line with slope 3 that passes through the point 2,6. So let's draw a picture of what we have. Plot the point 2,6. So if we start at the point 2,6 and then move to the right, according to our information, it has a slope of 3. So using that information, let's plot the direction of this line. A slope of 3 means what? It goes up 3, and then to the right 1. So if we increase to the right 1, we go up 3 units. So in terms of t, if we increase this by t, then what do we, if we increase the horizontal by a factor of t, what do we increase the vertical by? 3t. If we increase the horizontal by t, we increase the vertical by 3t. That would give us a line with a slope of 3. So now, just with the point that we have, x equals 2, y equals 6. Would you guys agree x equals 2, y equals 6?
Yeah.
So x equals 2. Let's start with that. Now, in order to go from this point here that we started with up to the second point, we had to add t to the x part of that. Do you guys agree? We added t in the horizontal, so it has to add to x. Now, the y part of our point was equal to 6. What did we have to add to the vertical component? We added t to the horizontal. What did we add to the vertical? 3t. And those are your parametric equations. They're pretty easy to find. We started with x equals 2 because that was the point that was given, x equals 2. And we also started with y equals 6 because that was the y value that was given. And then we just had to figure out what do we add in the horizontal, what do we add in the vertical. Since the slope was 3, we added 1t in the horizontal, we added 3t in the vertical. So these problems are pretty quick. One, though, on your homework, you have to think for a second. So let's take a look at an example like that. This will be our last one, then we're done with this section. It's kind of like this one, same directions.
Still a slope of 3.
No, it doesn't have a slope of 3. Find the parametric equation of the line that has this property. It passes through 1, 2, and 3, 6. Same direction. What are we missing, obviously? Slope. Pretty easy to find, though. Got to find the slope first, and then do the same exact thing we did on the last problem. So the slope is the difference in y values, 6 minus 2, divided by the difference in x values. So, slope is 2. Now what? Help me out. I can't understand you when you're all talking at once like that. It's hard to make out what you're saying. Okay, we can do that, yeah. If we plot the first point, 1. Let's say we started at this one, for example. If we started at the point 1, 2, then there x would equal 1 and y would equal 2. Now to go to the next point, we go over 1 unit and up 2 units, right? So we go over a factor of t and up a factor of 2t. So x equals 1 plus t plus 2t. Now, if you started with the other point and used the same slope, would you get the same exact parametric equations? No, they wouldn't look the same, but they would still describe a point moving along the same path. It just starts in a different spot. Does that make sense? So these answers need not be unique, but they do need to describe the same path.
So if we didn't do like the point we needed like x equals 1 plus 2 and y equals 2 plus 3. Because that's the slope from the first and the second thing that you gave us. Would that still be like
Yeah. It describes the same path, just starting in a different spot. So that would be one potential version of the answer right there. Anyway, that's 8.4.